I know that food is wonderful and the demos are really great, but we're going to get started. Good evening, my name is Brian Nagata. I'd like to welcome you to the Wireless Communications Alliance event, Industrial IoT, Gizmos and Gadgets. There's a burning question that people have been asking, and it's the question that everybody wants to know the answer, so I'm going to give you the answer. The question is, where are the restrooms? Go straight down this aisle, all the way to the other end, and you will bump into them. So when you need that, those are where the facilities are located. I'd like to point out that WCA, we're a all-volunteer organization, and we are always on the lookout for people who might be interested in helping out in any matter that, and any degree that might be of interest to you.
Sorry.
All right. Oh, okay. So if you're interested, we would certainly love to talk to you and get your input and get your help for WCA. A couple of announcements. As part of our, we're getting, anyway, Stu, where are you? Stu is our Secretary Treasurer, and he actually has, was the one who was the driving force to negotiate a discount agreement. So why don't you give a little bit overview on discount? No, you're the one who did it.
Well, I want to make sure I get the name correct. It's the IoT World Forum.
Yeah, I have a slide for it.
Oh, okay. Yeah. It's up there? Okay.
Well, later.
Well, we'll see if we can get to it. Yeah.
One more.
Okay. And I guess this will be posted on the website. Anyway, if you register for this event, whatever you choose to do, using this discount code, you can get a 20% discount. So that's it. And it's a 3-day event at the Santa Clara Convention Center. Should be very good. I think all this data will be on the website. So you don't need to take a picture.
Too late.
Anyway, thank you very much, Stu. Stu was the driving force to negotiate that for the WCA and for our members. Thank you very much, Stu. The event this evening actually was, the driving forces was Jeremy up here, and also Peter Walther. Peter, where are you located? Peter. Come over here, please.
I was busy grabbing some food.
I know you.
I'm losing weight already.
Were you the one who said that your wife told you that there was not going to be any dinner tonight? Or, oh no, that was Stu.
No, that was Stu. Right?
That was Stu's wife.
I said it.
Yeah. Anyway, thank you, Jeremy and Peter. And there's another ulterior motive that I got you up here. Yesterday.
Oh, we get paid?
No, yesterday we got paid. Yeah, twice as much as we normally do. Yesterday was Peter's birthday.
Oh.
So if you would help me by joining in. Happy birthday to you. Happy birthday to you. Happy birthday, dear Peter. Happy birthday to you. All right. So anyway, this evening, what's going to happen is we'll have some brief presentations by all of the presenters here, and we're going to ask you to keep it brief because I know that you would like to actually touch and feel and talk to these people about what they're showing. So if all the presenters would keep your comments to about 2 to 3 minutes, we'd greatly appreciate that. It will facilitate the evening. And so at this time, I'd like to hand it over to Jeremy, who'll give kind of an overview of WCA, brief, 2 minutes to 3 minutes, and then we'll introduce our moderator, and then we'll get rolling. Jeremy.
Okay, I'm not going to spend too much time on this because it's been looping through, and I'm sure everyone's been studying it, so it's going to be a test at the end of the night. But I want to welcome you guys to this second in a series of industrial IoT events called Gizmos and Gadgets. Kind of brief about Wireless Communications Alliance. We're dedicated to providing education, connection, and community to the wireless industry in Silicon Valley. And we were founded in 1994 as a nonprofit business league. We're all volunteer, as Brian mentioned, and our funding it comes from corporate donations and attendee fees. So thank you for everybody who's helping to support it. On the education side, we're trying to bring wireless into local schools, high schools, middle schools, universities, partnering with Silicon Valley organizations to sponsor students and give donations to schools to set up wireless environments, touch equipment, etc. The connection. Okay. The connections are what we've been doing. So we're helping people to meet each other with like mind and like interests. And community is this marketplace of ideas from wireless, industrial IoT, infrastructure, mobile, location-based services, smart grid, and other ideas that people here would like to share and explore. We can organize events around that. So our call to action is please sign up for newsletters and updates on the WCA.org site. That'll keep you abreast of these meetings. We have a mailing list, but not everybody seems to be on that, so we're trying to figure out how to make that happen. Peter and I have been sending out a lot of personal mails direct to people, and it's not super efficient, although we like to contact people. Sometimes we miss a few people and they get upset with us. Follow us on all social media. We're always seeking donations, sponsorships, volunteers for sure. We're looking for some more board members and some fresh, innovative ideas and energy. Stu already mentioned the IoT World Discount. This event is focused on industrial IoT versus IoT that is more for revolutionary ideas. We're looking at evolutionary things that are related to data, structured connectivity, mission critical, defined standards, and machine productivity. So that's the areas that we're trying to focus on for these types of events. So as I mentioned before, this is the second in a series of industrial IoT events. We plan to do more. We'd like your feedback on how this goes, what you'd like to see, whether it be areas in power, big data, sensors, connectivity, privacy, security, wireless power, AI, sensors, and so on and so forth. So anything that you could bring in, or ideas or companies that you want to see as part of this would definitely be appreciated. So without further ado, I'd like to introduce our moderator, Josh Bradshaw. He's the Director of Strategic Alliances for Radius Innovation, which is a design consultancy within Jabil. He helps to organize and facilitate the IoT Inc. Meetup group alongside Bruce Sinclair, and IoT Inc. Meetup is actually a co-sponsor of this event tonight, so we appreciate that and bringing in some new faces. He's extremely passionate about value generation from the Internet of Things, as it ties directly with his personal mantra. Don't work for technology, make technology work for you. And he blogs on his topic on work.com. Josh.
I don't need this. I just wanted to add one more thing. The conference is in a couple $1,000 range, but if you register quickly, you can get an exhibit pass for nothing. I know they'll close that window and move it to 50 bucks eventually, but right now it's still free.
Okay, I'm mic'd up. Can you hear me? All right, so we're having feedback issues. Those of you in the back who can't hear, y'all would fit right up here very nicely. So if you can't hear, come on up here. I'll try and speak loud. That's usually not a problem with me. I'm happy to be here tonight representing the IoT Inc. meetup. How many of you have been to an IoT Inc. meetup? All right, got quite a few here. Good, oh yeah, some nice familiar faces here. So IoT Inc. meetup is all about finding value. IoT Inc., like incorporated, finding value in the Internet of Things. So we're really happy to be here together with the Wireless Communication Alliance to talk about that topic precisely here tonight. And he was mentioning the social media, so I thought I would try and do a favor. I'm going to take a selfie, and so all y'all with Twitter, I'm going to tweet this right now. Go ahead and retweet it. I've tagged the WCA, so go ahead and we'll send that selfie out to the the greater internet, see if we can get some activity on the WCA.org is the Twitter handle. Go ahead and follow them if you aren't following them already. So are my slides in here next? Nope. I only have a couple of slides. So my task tonight is to moderate. So here's the rules of the game. We have several presenters. They've all been given 5 minutes and 1 to 2 questions. Okay? So that's going to be the pattern that we'll go through tonight. You'll have 1 to 2 questions. We'll have a microphone for those questions. Those questions better be good, and they better not be long-winded, or I'll start making some weird animal noises or something. At the end, we'll all come up to the front and we'll have a couple of quick questions and answers at the end as a group, and maybe have a little bit of more rounded conversation once we've kind of laid the foundation of 8 or 9 really good examples of value generation from the Internet of Things, which is what this is ultimately all about. All right, so I am at Radius, which is a Jabil company. Many of you will know the manufacturer Jabil. We make a lot of stuff. You probably touched 10 or 15 things we made here today. Radius is the design arm, and I'm Director of Strategic Alliances there. Our plan for tonight is to intro. I'm going to give a couple of examples, and then we go through the pattern I just described. One thing that's not in my slides is that if you'd like to come down to Jabil and check out our facility, next Wednesday we're opening our doors as hosts for the Silicon Valley Robotic Block Party. So if you're into robots, who's not into robots? Who doesn't like robots? Raise your hand. All right, so y'all will be coming. Check out the Silicon Valley Robotics event. It is next Wednesday, free and open to the public, and you can bring kids. So another great opportunity. Unfortunately, I don't have a slide on that, but I did want to mention that. We're all IoT gurus, and we'll have actually, Jabil has some manufacturing robotics things that will be on display there. You can see some IoT and automation mixed solutions, and I'll talk briefly about one of those. All right, so big picture, this is a lot of the area of the IoT where we play. Tonight we're going to be talking about commercial and the factory of the future a little bit. It's kind of washed out. Radius's task, where what I do for a day job, is to help folks bridge from idea to reality, right? Getting your product to the market. But enough about me. We're talking about the IoT tonight, which is where we really get the chance to put technology to work for us. They already talked about my mantra. I love finding ways to put technology to work for us. So I have 2 examples. Now this is being recorded, right? So I can't speak about client names, and there's confidentiality things, and so that actually made it quite challenging to find the example. It'd be nice if we could have Chatham House rules and talk a little bit more openly, but I found this example in our deck where we've created a smart shower solution for the hospitality industry. And what this does is it enables them to tell exactly when the shower turns on and off in every single room. Now, for hospitality, that's interesting. It's not necessarily industrial IoT, but the exact same technology can be applied to every valve with any liquid in any manufacturing environment. Okay? So I can't show you those, but I can show you the smart shower and let your minds go to where, you know, this is really possible and it's really generating real value in the industrial IoT. That was a design project, by the way, by Radius. This one is a Jabil example. This is a PLC unit right here. It's on a machine. PCB boards are coming off of the machine, and there's a sensor here. So the PLC knows when the board is in place. It tells the camera, which camera is the IoT sensor of the future, guys. With machine intelligence and the ability to do image recognition, camera is the sensor of the future. It scans the board, sends a date and time stamp to the server. We know the exact moment when every single PCB board rolls off of that machine. Right. So when you're a large manufacturer like Jabil and you're doing things like making 1 million cell phones a day, this is really valuable. This is data-driven industrial IoT in the manufacturing process. All right, so I think I've done it in less than 5 minutes, right? That's the goal. And I'm not going to take questions unless somebody really has a burning question for me. What I'd really like to do is get going on the next presentations. But I will, one question if you have it. Going, gone. Okay. So the next thing we're going to do, so we have had a high amount of compliance as far as providing me with bios, because I threatened them to make up facts about the circus in their previous careers. And so Sam was, I believe, the first person to get his bio to me, so he's going to receive the less amount of flack from the introduction police here. So he's currently Director of Sales here at Imagination Technologies. He was a founder of IP Semantics as an IoT IP sales and ASIC design, I guess that's how you say it. He's held several sales, business development, and fab management and circuit design positions in companies in the semiconductor, wireless, and RF technology markets. A lot of small names, companies he's worked with, as well as IBM, Siemens, and Intel. You have a BS in mechanical engineering, and from Louisiana State, right? And this is the important part, shares an alma mater with me, an MS in engineering from San Jose State University.
Oh, great.
Join me in welcoming Sam.
All right. With the microphone.
So Imagination Technologies is a UK-based company. We're about 1,200 people. We only license IP. We don't do anything else but license IP. There are three major BU, business units, that we pride ourselves in. The first one is our graphics. We have the best embedded GPU. As you probably have heard, we're into Apple and we're having disputes. We provide very unique set of patents to our embedded GPU, such as tile rendering and ray tracing. We have a good, very good general set of GPUs that we can provide to the market. Along with that, we have video encoders, decoders, ISP as well. Our second BU is our MIPS. So you folks are familiar, we acquired MIPS a while back. So we do with our MIPS multi-threading and multi-cluster. We found some new opportunities in the HPC market with this, along with some of the old ones. The last but not least is the IoT sector. So we provide you, the customer, IPs for RF and baseband for our wireless standards, from LTE category 0 down to ZigBee. For this particular forum, I even have a platform. This platform would help you demo our Wi-Fi, one by one, or our Bluetooth, and of course our ZigBee. This platform allows you to have access to the IP basic building blocks. And we also provide end-to-end security. So I know at the end Josh is going to ask me, well, what's your value add? So Imagination Technologies value add is to provide you the basic building blocks for any IoT platform, and of course to do security. So let me, in favor of the time, just jump into some of the platforms you see here. It shows you the different applications we've been into. So what I want to emphasize tonight, in addition to our wireless standards, is our end-to-end security IP. So if you were to use a MIPS processor in one of your IoT design applications, we provide a virtualization, which is a concept by which we create separate silos with a root of trust, and therefore avoid any kind of cross-contamination between different OSs that you might be running on your IoT. We have a platform here for demo on the table as well. So again, any IP that you need, baseband and RF, for your IoT platform, along with complete secure solution. So I would just, these are some more examples. I have my business cards on the table. If you need specific information on any of this stuff, especially with regards to IoT, I'll be glad to provide you more information. That's just about it. I don't want to get too much detail into this, but again, I really would like for you to take away from this. You've heard IoT a lot, but secure IoT is huge. It's coming down as a big problem. The way we think there is a good solution is by creating different silos and a root of trust, and therefore allowing the different OSs to operate separately. I have a platform here for any type of IoT play that you want to do. It's called a CI40. I'll be glad to provide one of these platforms. This is more specific on this. And I think I'd just like to wrap it up because of the 5-minute time I have. If you have any question, Josh has told me I can ask for 1 or 2 questions and answer it. Else we can try to answer any question at the end. Okay, I'm a good citizen, 5 minutes under, right?
5 minutes, no question, no question? All right. Well, Sam, before you go, let's see, mine's not working. I just want to say a special thank you because having been an event host myself, I know the logistics involved with pulling this together and having this many people. Could you guys give an extra round of applause to Imagination for being All right, so next up we have Vincent from Abzil Corporation. Vincent, where are you? Oh, there you are. Now, the most important thing about Vincent is actually not in his bio. Vincent has a 10-month-old baby, right? So amazing to be out on a. Congratulations to your wife, who's also helping him be here tonight. But being a parent is almost as hard as finding value in the IoT. Okay, so Vincent is Director of Business Development at Abzil. He develops control solutions for a range of clients. His focus is geared on system-level automation for semiconductor processing, alternative energy, and earthquake safety. He's worked in a number of Silicon Valley companies and having an impact there. Vincent, I look forward to hearing from you.
Good evening, everyone. Tonight I'm going to go over a little bit about Abzil Corporation, as well as some information about how we can predict early failure detection. So in the heart of Abzil, our tagline, Automation Zone Builder, we're really about integrating machine automation with human safety. And again, our tagline being human-centered automation, Abzil really provides a number of solutions for both commercial as well as factory plant level type automation. And just a quick dive on the types of products and services that we provide for commercial industry. You'll see a number of sensors, actuating devices, and control product lines for building automation. But in particular, we're really focused on like energy saving, so things like HVAC lighting, we try to control. And from a factory automation perspective, again, a lot of sensor, a lot of control type of products that we currently provide, really just to monitor any critical variables that are there to keep the plant running. And with that, I'd like to kind of go a little bit deeper in terms of what the typical architecture looks like for a factory automation. For example, right now we have down here example of a variety of discrete devices that are connected to a PLC. And typical PLCs are used for process control, basic diagnostic, and if needed, like an emergency shutdown. And a lot of that data gets collected and transmit it to a control center, which then could do, the operator can do trend monitoring, some risk assessment, and as well as some plant shutdown. But nowhere in this particular schematic do we have the capability of doing, product failure prediction. That is both cost effectively as well as working with existing assets. In particular, like in this case, if the device on the plant somewhere is failing, how do we detect that? So with the ability to work with existing assets, Aspen has introduced a data collection controller. Here you see that there's industrial sensor devices that are connected through a legacy analog network. Very reliable, but also very limited. At the same time, a lot of these devices have some smarts in them. And with this new controller that we're introducing, we want to be able to extract those data into a faster, more capable network, and be able to transmit those, connect to router, transmit it wirelessly, or directly to a factory level. And beyond just collecting the data, we have the ability to do some predictive analytics. And there's some few examples of what we can do. For example, we can do some typical limit monitoring. Here's high limit, low limit, anything outside of that, it's an alarm. We also do some deviation monitoring where we take critical points on a bell curve before and after a process and make sure there's nothing changed. If something changed, that's an alarm for us. Or we can also do some trend comparison, just comparing with a known working process and just compare the data over and over with it. But what Aspen has introduced is a new way of doing predictive analytics by taking an actual process condition, taking real-time sensor inputs and real-time control outputs, funnel it into a PID loop, and at the same time comparing it with a simulated process condition. And by comparing those two, we can get some kind of index. And as you can see here on the right, looking at the index, we can track the performance of, I should say, the condition of components within a system. And in this particular case, as the degrading state of this condition, it probably turns out to be like a clogged filter. So this is what we call like the health index. And it's the ability to monitor both the discrete components as well as a system. And again, these data, once we collect them, it's, in this localized controller, can then get pushed up to a factory level computing, and then if needed, up to a web services for heavy analytics, and then whatever results can come right back down. This is what we envision our product playing a role in the larger system level. But with that said, I think that's actually it. Any questions?
Y'all are too quiet. There we go.
Damn it. I have a really hard question for you.
Can you
No, it's not working.
I just wanted to ask if you have any products or initiatives where the sensors are actually on the humans as well.
Right now, sorry. I think the question was, actually, I think everybody heard the question. Right now, I don't think there's anything we're doing on the human body in particular. We're a little bit geared towards the industrial, again, more for process improvement, optimization of manufacturing process. That's kind of where we're heading towards. But doesn't mean it won't happen in the future.
Other than accessing the cloud, I didn't quite see how you use the internet in your architecture.
That's a good question. That's because we're not. At least for the time being, we have the capability of doing localized computing. Because the reality is a lot of these industrial instrumentation, they're designed to work for many years, 5 or 10 years before you start seeing signs of wear. So to start collecting data from day one, I think you're gonna end up with a lot of data. So with this device, it actually has the capability of selecting a very specific trigger point. Meaning, like if you run a process and we see an anomaly of some kind, that could be a trigger point for us to start collecting data. And we think that's actually the right way to do predictive analysis.
That was 2 questions,
Yeah,
right?
we can circle back later.
Oh,
Yeah, one more. How do you find, are customers letting you in as you intrude on their processes? How is that going?
Well, being in this industry for over, I mean, we've been in this industry for a very long time. I think we actually bring up these opportunities for customers. So not so much as intruding, because we understand the applications very well. We understand where value could be created with some process improvement.
all right, thanks, Vincent. That was great. So. All right, so next up we have Shadi Hawanini.
Hawaii, yes.
Hawaii.
An easy one, yeah.
Fortunately, I won't be making up circus tales about you, but I have some good stories about Psychic. So I discovered Psychic probably 3 years ago, and got me really excited because I was spending a lot of time in wearables at that point in time. And so having something that's very ultra low energy, that can run essentially forever inside of an IoT device that's on somebody's persona was very exciting, and I'd interviewed their CEO and published a bit about them. And I didn't tell you this, but I have, every time I've spoken at a conference or event about wearable technology, Psychic's logo has been up there.
Well, we appreciate
So,
it. Thank you. Yeah.
I've been a fan
It's
for
great
a
press.
while. I didn't even know you guys were going to be doing this when I found out I was moderating. So you're the first Psychic person I met in person. So
Fantastic.
thank you.
Yes.
So he is in charge of marketing at Psychic, and he's in charge of customer application, systems integration, product definition. And before Psychic, you were at Qualcomm and Summit Micro, where you ran the battery management systems groups. So without further ado, I'll turn it over to you.
Thank you. All right. Good evening. All right, so I'm going to start off by giving sort of a view of the world from a Psychic perspective. And I'm sure you guys talked about this at length. But the idea being is that, everyone is trying to sense everything around them. And the challenge is when you're starting to talk about such huge volumes, and we talk about huge volumes as in trillions, really sensing everything around you. The challenge with having a battery is you can't. It doesn't scale. It's a big, big problem. And Psychic has been fundamentally started under this concept of batteries do not scale. And with all these sensors, we're really looking to deliver real meaningful insights, real valuable data. It's not a connected toaster or anything like that. And so one of the things that we found is, where is there a lot of value to be had? Industrial is a very attractive area. And so we've had a pretty big focus largely on the industrial side of things. So we sort of view computing in this linear way, and we talk about 50 billion connected devices by 2020. There's the Gartner research and a whole host of other research outfits saying similar numbers. But again, these are all based off of BLE or Zigbee or other types of modalities. And again, they're fundamentally limiting because they have to be battery operated. What we look at seeing the next generation of 1 trillion, and there has to be something just completely different that has to be done. And we believe that we're hoping, I should say, to enable this next wave of pervasive computing. The idea is you can embed compute into pretty much any device, regardless of the size of said device. So The challenge, of course, with scaling is batteries. Today, you look at most systems, and they consume on average tens of milliwatts. The challenge is if you have batteries, you're talking about hours, days, perhaps a year, 2 years. But for a lot of applications, people are looking for 5 years, 10 years, even 15 years of runtime. And so if you have a battery that's in a system consuming tens of milliwatts, it's just not going to work. So the answer is, well, why not do energy harvesting? Well, the challenge with most energy harvesting solutions is you generate tens of microwatts of power per centimeter squared. The challenge is you're creating a power envelope that is far too low to do most things meaningful. The second you go and try and send a couple bits of information across an RF link, you're going to kill your system. So the challenge with energy harvesting is you generally don't have a big enough power envelope to do much meaningful things. So where we come in as Psychic is we fundamentally develop silicon that operates at about 1,000 times lower power than what you can buy on the market today. And so at 1,000 times lower power, we're talking about active average system power consumption in the microwatt level. And that includes RF fully on, actually doing processing at the node. And we believe that all of this can then, of course, be powered entirely by an energy harvesting source. And we believe that this unlocks completely batteryless sensing systems. So there are still challenges with deploying these huge numbers, which a lot of people are addressing. Software integration, deployment efforts, physical support, tethering requirements. And so the challenge is not just developing the silicon itself or even the system, but it's really having sort of that end-to-end protocol. One of the challenges that we've observed in the IoT is there are so many moving pieces that for one end customer to go and pull everything together is a huge effort. And so we've actually taken the challenge to go and facilitate getting sense data into the cloud and doing so without batteries. So the secret sauce for what we do at Psychic, we sort of broadly categorize it in 3 different categories. The first is the digital side, the processing side. What we do is we actually do all of our digital processing in sub-threshold technology. So if you think of power as being a V² term, we're at 0.5 volts. So you can imagine the power level is very low. The second is for the low power RF. We have a lot of expertise in low power RF. Our radio, for example, in a receive mode, always on, consumes 500 nanowatts of power. So sort of in the noise of most power budgets. And finally, it's pulling everything together. It's the system level integration. It's having a protocol that consumes very little, or I should say, transmits the fewest amount of bits to actually get meaningful data across. And similarly, we like to joke that we're incredibly good at turning things off. If we're not using something, we turn it off. You don't burn much power that way. So we also have a partnership with many different energy harvesting providers. Our solution is modular in the sense that the platform itself is scalable. So depending on a particular application, we're able to enable things that harvest from PV, from thermoelectric, from vibration or motion. So all of these energy harvesting modalities are supported as part of our platform. So the benefit, of course, is under different applications, motion harvesting might be useful because generally speaking, PV is easy to understand, but there are lots of problems with PV. When the lights are out, you don't harvest from PV. It doesn't work very well. So finally, the data acquisition system that we've created, in effect, has what we call smart sense nodes. And these smart sense nodes are completely batteryless, wirelessly connected devices that are capable of doing things like temperature, humidity, motion sensing, pretty much any sensing modality for most applications, powered entirely off of harvested energy. These then communicate back to what we call our control nodes, and from the control node, we're able to do some localized processing and then push that data to some cloud interface or some local data storage. So it's basically, as we view it, the easiest way to get sense data into the cloud, and all the while doing it without having batteries. So I'll end with this. This is a number we like to throw around a lot, but if you have trillions of sensors at milliwatt power levels and you have batteries, it doesn't work out. So if you have a trillion sensors, and let's say best case you get 10 years of batteries, that translates to 275 million battery replacements every day. Doesn't scale very well.
It's probably not going to happen.
It's not going to happen, exactly. That's exactly right. And so we view energy harvesting as the fundamental game changer here. So thank you very much, and any questions?
On the microphone.
If I understood your wireless setup, you've got to have your gateway then to communicate with your nodes?
The way it's architected today, yes. It's sort of a vertically integrated solution. The future plan is you know, a little bit more flexibility there, but yes, the current implementation is using our own control node. Basically, the communication from that control node to what we call the Smart Sense node is basically a proprietary communication, like one of the ways we're able to get to such low power levels.
When's the first product to come out?
We're piloting today, and we're expecting production in the year.
Can you say a few words about the data rates you can support?
Sure, yeah. So, you know, most of these things that we're supporting, I wouldn't say are streaming raw data. You're talking about sensing things like temperature, humidity, or even vibration at lower interval levels. So, for example, transmitting data every second or a couple of seconds are sort of the data rates that we're talking about. Great. Okay. Thank you, Josh.
Well, thanks. That was great. He didn't quite patch it out the way that I see it. I see two ways of solving the energy problem. One is reducing the amount of energy that's used, and the other is being able to increase the battery storage. Mm-hmm. And when you were talking about turning off the sensors, one of the things their CEO had explained to me is that they've been able to figure out how to use the energy that trickles through the sensor even when it's turned off. Mm-hmm. Right? So there's a lot of escaping energy, and if we can capture all of that and then do the other things as described here, that's kind of how we're going to get there, imagining that kind of a future. Okay, next up we have Zeki Ganai from Kratos Technology. So Zeki brings a wealth of experience. They're creating IoT, they're a product development company creating IoT solutions in markets with products and product development engineering services. Zeki comes from a semiconductor background and served in leading semiconductor companies here in Silicon Valley. So with 20 years of experience, we welcome him to serving us in the IoT, greater IoT community with his innovations at Kratos, which he's going to tell us all about. Join me in welcoming Zeki.
Thank you. Good evening. So thanks for hosting us today, and thanks for letting me talk. There's a lot of familiar faces. Mr. Author Dr. Moss is here, and then a lot of friends and co-workers. So Kratos is an intelligent sensing products company. We have started as a product development company about 4 years ago, and then shortly after that we got into services business, and we provide engineering services for various IoT markets and verticals with industrial design, mechanical design, electrical design, firmware, software ability. Basically, take concepts all the way to from concepts to manufacturing and manufacturing support.
Could you get closer to the mic? Yeah.
Absolutely. How is this now?
Better. Yeah.
Excellent. All right, so we're an engineering services company, so we take the ideas all the way to manufacturing services. As I said, all the engineering is done in-house, and most products are IoT products. We specialize in sensor-centric products, sometimes come up with the sensing modality, and in some cases integrate other IP, readily available IP, and we basically come up with the end-to-end solutions all the way to data systems up in the cloud. One example is a new data logger that we're working on, for example. This is for industrial use and also medical use, capable of monitoring temperature, humidity, barometric pressure, and storing the data for an extended period of time in the case of no wireless communications. Whenever there's a wireless network available, we push the data to the cloud. Also, in industrial domain, we have a lot of activity going on. We believe in the presentation and transmission of the data that makes sense. Appropriate presentation, efficient presentation of this data is very, very important in industrial applications. And we basically strive to create these experiences for the operators, for the field personnel, maintenance crews, and so on and so forth. Today we're showing a demonstration of a concept which is basically transmitting data, real-time data from sensors directly to the Microsoft HoloLens. We have developed a software solution between an embedded device, an embedded microcontroller, wirelessly communicating to the Microsoft HoloLens, and you can assign real-time data to their sources in 3D space and pick and choose from a simple menu which data you want to display or what kind of statistical information you want to display in your HoloLens. So hands-free, you can walk into the industrial environment, and whatever data you have picked and chosen coming from whichever device, you can see it there every time you walk through that industrial environment. So it's pretty useful for maintenance crews. It's very useful for outdoor maintenance crews, especially for PG&E executing a work order in a box out in the middle of nowhere, and hands-free they can actually have access to the data in front of their eyes. So the delivery of the data is what we concentrate on. Here's a little summary slide of what we're presenting today. The Blue Brain is our product, which is basically an industrial quality sensor data acquisition and telemetry platform where you can actually connect hundreds of combinations of sensors to this platform, either store data or transmit data wirelessly. In this case, to a Microsoft HoloLens. The same device exists in a portable fashion. It's the platform that we have developed as well. It's got environmental and motion sensors on it. And again, data can be presented on either a network, a mobile device, or Microsoft HoloLens. I just wanted to keep it short and sweet today. So, brief introduction to Kratos, and if you have any questions, I'll be right by the monitor. And thanks for listening. Thank you.
Is there a question now?
Any questions?
No? Okay.
No questions.
After-
So there's probably like one question asked today, or two questions asked, right? So far?
Yeah, one or two.
One or two.
Yeah. Cool. All right, so next up, we're going to welcome, let's see, Mike McDonald. There you are. So we have Mike McDonald from Toshiba. He's an experienced veteran in the semiconductor industry and leads a technical marketing group inside of Toshiba that matches up new and emerging technologies inside the company with external players and vice versa. Sounds like a fun job. His team manages Toshiba's activities in the Bluetooth Standards Organization, and Toshiba is a founding member and board member of the Bluetooth organization. So join me in welcoming Michael. Good to have
Yeah, so thanks to the WCA for inviting Toshiba. Toshiba is actually one of the founders of the Bluetooth organization, so we've been involved in Bluetooth for quite some time. We sit on the board of directors. We're actually the only semiconductor company on the Bluetooth board of directors, so we're very active in the Bluetooth organization. If you drive around San Jose and you see a white car that has the license plate Bluetooth, that car is actually owned by Bill Drake, who will be giving one of our demos today. So he has been doing Bluetooth for more years than he cares to admit. So he's Mr. Bluetooth. Everybody knows him if we're a Bluetooth world. He actually spent a number of years over at Emerson, both working at Emerson and selling products to Emerson. And he has educated me in terms of all of the different places that Bluetooth has application within the industrial space. A lot of times we think of Bluetooth as, okay, it's good for being able to do the audio, and now maybe it's good for Alexa and all of that. But the challenge with home automation is it's often for convenience. The person doesn't want to get up off the sofa in order to turn off the light. The person wants to be able to reach into his phone and control the TV with it. It's convenience. And it's difficult to get an ROI when all you're doing is offering, you're enabling when you're just doing something for convenience, it's difficult to create an ROI. But what's real nice about the industrial space is there's a real ROI when we start putting a lot of communication inside of the industrial space. So preventative maintenance, if you have a compressor that goes down unexpectedly, then that costs real money, say on an oil rig. So it can cost thousands of dollars a day. So being able to put more sensors on there is a great way of being able to handle things like preventative maintenance. But you have issues like cabling. Cabling is expensive to lay out in industrial environments. You also have outdoor environments where cabling is very expensive. So Bluetooth wireless and wireless technology is a great way of being able to put a lot more sensors inside of the factory, and it has a direct impact on return on investment. So it's a way of being able to run your factories more efficiently and keep the uptime up. So it's helping top line. But you're also able to handle yield issues, see how something is working, and be able to make adjustments. So there's a top line and a cost benefit that Bluetooth really enables with the industrial space. Let me spend a few minutes and just talk about the demos that we're showing over there. One of the demos that we're showing is a long-range demo. Bluetooth gets a lot of grief of, hey, I lost my connection when I stepped 20 feet away from the sensor. So what we're showing is a Bluetooth device. It's +7 dBm. And what that allows us to do is, from there, I was in the next parking lot over, 5th parking spot from the end. So about 200 meters away, using the little module that's there. This is a PCB antenna. So it doesn't even have a little, I'm sorry? Yeah, it doesn't have a big antenna. So this is just the PCB antenna. I'm transmitting 200 yards. So that's one of the demos. I'm not going to go into the parking lot anymore. It's wet out there. Just have to take my word for it, or maybe we can go wander around the building and you can see how it goes through all of these walls. So very good transmit performance. One of the other demos that Bill will be showing is with the HoloLens. And when you look through there, you'll see a virtual factory environment. And what you'll be able to do is take a look at a motor, and you'll see what is the RPM, what is the temperature of that motor. In theory, if there was a stator or something that was broken there, and some vibrations that might be there, the person who's wandering around the factory floor would be able to look at that and see, hey, there's an issue that's there, because it would be communicating via Bluetooth, to that headset. So that's one of the other things that we're showing. One of Toshiba's claims to fame with our Bluetooth silicon is very low power. So we transmit and receive at 3.5 milliamps. And so what that means is using a CR2032 coin cell battery, if you were to transmit something once a second, you would be getting over 3 years of battery life using that CR2032 battery in our silicon. So very low battery life. A lot of industrial customers, and actually a lot of customers all over the place, they don't necessarily want to become Bluetooth experts in order to add Bluetooth to their device. So we work with module companies. There's some information on Panasonic. We also work with Fancell. The nice thing about modules is they already have gone through all the Bluetooth certifications. They've gone through the FCC and EU and JP and all the different regional certifications. And so that means you can put this Bluetooth module into your device and not have to worry about any of these certifications because it's actually coming with the module. So there's some information on that. One of the devices that we're not showing today, but that Toshiba is very excited about, is an industrial controller. It's the TZ2100, 600 megahertz controller, 24-bit GPIO. So you could put, for example, a measurement on the current that is going through a wire, just checking the magnetism or the current flow through there, and you would be able to see how much current is going through that particular line. you can do very high precision measurements with that 24-bit A to B converter. With 600 megahertz, now all of a sudden you can add things like machine intelligence. So you can see when a device is starting to go out of alignment and figure out, okay, hey, this is not the way it's been operating for the last 365 days, so I need to send out an alert. So adding things like machine intelligence with this performance. So we'd love for you guys to stop by. I do have some giveaways that if you guys take them, I don't have to worry about sending them back to Southern California. So help me out there, and I'll take any questions. All right, thank you.
All right, next up we have Trevor Dungoy. I'm sorry, I didn't ask you how to say your last name. I didn't know it was going to be this hard. So he's VP of Sales at Cassia Networks. A lot of experience with Bluetooth networking and IoT, helping customers build seamless Bluetooth networks to improve CX, OpEx, and realize the real value in the IoT. Last night, he got a call from his wife on his way out of the door telling him that, oh, by the way, go pick up the food. We're having a birthday party with 20 kids. And then I asked him, I said, well, which is harder, finding value in the IoT or a birthday party with 20 kids? And we'll let you hear from him what the answer was. Thanks, Trevor.
I haven't found any value in the IoT yet. but we'll keep looking for it. So wanted to thank everybody for coming out tonight. Appreciate the invitation to participate and speak. I'm actually going to work very hard at staying within my time allocation because I've got kids waiting for me at home. So Cassia Networks, very much, we're talking about this trend, everybody here, different analyst metrics looking at adding 15 billion devices to the IoT, the industrial IoT, over the next few years. It's a lot. Anybody's counted them or not. There's no single IoT standard. We've heard a few different alternatives. Zigbee, great talk, Michael on Bluetooth. That's where I'm going to land, just in case anyone's wondering. The Wi-Fi out there and Z-Wave. We think, I really didn't want to do that, but I don't know what's causing it.
Feedback.
Yeah, from what though? What's the other thing? Okay. You gonna press the button for me?
Oh, sure.
All right. So, right here. Is this good? Okay. I have to do this because I have to read off my slides. Bluetooth best position for IoT. So we think low power, low cost, small size, huge developer community. So there's lots of people that develop sensors, very mature manufacturing. 3 billion plus shipped in 2015. Might have been more than 4 billion in 16. And it's very open. So we at Cassia Networks are a big fan of Bluetooth. Next slide, please. Wrong way. However, poor range, 10 meters. Right, so I heard a story about someone struggling with their mouse today. They were very much not a fan of Bluetooth at the moment. One-to-one pairing, no remote control. That seems to be what everybody thinks about Bluetooth today. Interestingly, it's actually been changed for some time. This is really very much associated with Classic. 4.1, 4.2, the move to BLE changed a lot of these types of characteristics of Bluetooth. Next slide, please. And so, for those who can read quickly and read small text, a bunch of things. What I found interesting as I put this together, BLE is, I don't know if this is retrograde marketing, retroactive marketing, but the SIG is saying ideal for Internet of Things. And so I don't know if that was the original intention, but I found it kind of surprising that they were looking at that, because a big part of what I wanted to sort of bring light to in my conversation with you today was that everybody seems to be waiting for Bluetooth 5, and don't really see the need for that. Very much about sensor networks, which we heard a number of opinions on earlier in the conversation. And you can see BLE, 100 meters of range. Michael gave us an example that he's achieving upwards of 200 meters. And with Bluetooth 5,
We hear 2 times the speed, 4 times the range. A lot of people put an and between those two things. There's trade-offs. It's or. At Casio, we've invested heavily in our antenna R&D, as well as some filtering technologies. We're achieving more than 300 meters of range with what we describe our products as Bluetooth routers, the ability to penetrate up to 3 walls with standard BLE devices, and providing an SDK. So the other challenge that it's kind of hidden by me, but traditional Bluetooth are custom profiles. So our SDK allows you to map to any profile. The big move with Bluetooth 5 is to create some standardization around those profiles and improve the device mobility, if you will. While everyone looks to Bluetooth 5, I assert that actually BLE works quite a bit better than Classic, and that we at Casio Networks are taking an enterprise networking approach to enabling IoT networks using Bluetooth. Next slide. And so I invite you to unlock the power of IoT, leveraging easy deployment and management with our access controller software, and enjoy the superior ROI if we find the value in the IoT. That's all.
All right, questions?
Do you have the combined solution of RF and baseband for this?
No.
No. What exactly is it? I'm sorry.
So it's Bluetooth access points.
Just access. Got it.
Yeah,
Thank you.
and deployed with a software-based access controller, so you can build a seamless Bluetooth network at scale.
I got it. Thank you.
Okay.
And so you're shipping today, and into what major segments?
So yes, we are shipping today. As you can imagine, we see a lot of interest in healthcare, fitness, sports, wearables, anything around the person, because there's a very rich ecosystem of wearables that are driving that. Environmental is another space with temperature control, vibration control, where there's a good body of sensors, which means we're in manufacturing. We've got a lot of interest in POCs in transportation, and smart office, and some asset tracking and real-time location services as well. Okay, thank you.
All right, thanks, Trevor. All right, next up we have Ashish Singh. Now, like me, and I'm going to confess something here that it maybe isn't the most sexy thing to say in Silicon Valley, but I'm a technical person with an MBA. Ashish is also a technical person with an MBA, so don't throw tomatoes just yet. But I love his slide because it says business value in industrial IoT. So I'm looking forward to hearing about that from you, Ashish. He has over 15 years of experience in product management, technology architecture, and market strategy in the areas of the industrial IoT, smart cities, and ITS. He's focused on building products, leveraging new software architectures, restructuring current business models. Look at that, business models in a tech meeting, I love it. And helping their end customers. So he has a BS in computer engineering and an MBA in marketing and strategy from Ohio State University. Please join me in welcoming Ashish.
Thank you. Yeah. Yeah, I think probably just next slide. I will use my 5 minutes here. So I think one of the challenges, we are a spin-out of SK Telecom. We spun out in 2016. And the value we bring is, when we looked at the industrial IoT applications, a couple of challenges we saw everywhere was ability to manage the brownfield deployments as well as transitioning to a greenfield deployments, leveraging the new technologies and models and new networks and protocols you have. So most of the deployments you will see one of these challenges you are having. You have different sensing capabilities, you have connectivity based upon what the applications are. You will always encounter multiple connectivity problems, multiple connectivity applications. Sensor power, you may have different sensor power based upon what the application is. And then security, host of security standards are there. So the complexity for an industrial consumer or industrial user is the ability to create an ecosystem where they can quickly start getting the value out of their installations by not only communicating, collecting the data, but also creating the business model in the back end to create some kind of a real-time billing engine on top of collecting the usage-based billing on top of it. So when we look at the industrial IoT, we look at that in this perspective. We say that in a 4x4 quadrant, you have a physical and a virtual and unobstructive and obvious architecture, and you are at any given time trying to fit into one of these applications in any 4 quadrant. And based upon where you are trying to fit your business application, the technology you are trying to use or the processes you are trying to use will differ based upon which quadrant you are trying to use. And that's where the challenge of how do you create an end-to-end architecture or a product which can solve all these 4 quadrants. Maybe in some business units, you may be always using one specific quadrant, but in a very large conglomerate kind of application, you may end up using more than one quadrant, and you will try to always strive to use the best technology, best data plan you have, or the best data model you can use to fully justify the application of that particular quadrant. Other applications we are seeing is the convergence of industrial IoT with industrial variables, or what we will call it as an ambient user experience. And what we are trying to solve the problem here is that as in case one example we looked into was the connected tools solution, where there is a human interaction that is happening, and it's a large industrial application. And in the connected tools, there is a variability in how a particular human is trying to measure a certain amount of data from that particular large equipment that he is using. And there is an industrial IoT application where they are trying to justify the variability in the measurement is how much is that dependent upon the human that is using it, and how can you reduce that kind of variability. So again, the challenge there is industrial IoT in a more personal space, and how do you provide that information at the time of measurement, and also capture all the other sensory information that can be done or that can be captured, so that in the later you can do the analysis, identify the variability is based upon the human that is using the processes to do the data capture, or is there some other value or some other variability that is being introduced. So from all that, basically you will capture the data, and what we have seen is there are 2 ways you can export that data or get the value out of that IoT data that you are trying to capture. One I would call is to build new revenue sources, or you can improve the bottom efficiency. So typically you can say, hey, from the application of industrial IoT, either I will try to increase my top line, or I will use that data to improve my operational efficiency. And eventually you want to increase your profit margin in whatever business you are doing. So these are some of the applications that we focus on to solve more specifically in each of the 2 ways in which you are trying to capture and get the value out of the data itself. This is some of the application as we look into the different data. Next problem that is coming is the ability to do the distributed intelligence at the edge. Some of the things we are working with is licensing the gateway and the software we develop to solve that particular problem at the edge, not only from a data processing perspective, but also from the data usage perspective, so that you can define a real-time models on, for example, we are working with some industrial customers where they want to charge based upon the machine used in specific applications, and you don't want, how do you solve a problem of collecting that information, bringing back all the way to the data center, and then charging for that particular usage? Is there a way we can, so the challenge for them was, is there a way they can create a usage on the machine itself, and then have a running counter of the amount that a particular facility that uses their machine can find out at end of the day how much they owe the equipment provider who is providing that machine to them. So how do you combine the usage problem to the pricing problem in industrial application. And what we are seeing is, in the end, what you're trying to do is, starting from the left-hand side, is you are in an industrial IoT application. There are a lot of ways in which data input is coming. It is a streaming of data, it's a geospatial data, there's a situational data. And eventually what we are trying to achieve is an automated way of making the decision and getting the best usage information out of the data that is coming out from the data that you are capturing. The life of the data determines the information that you can extract from that particular data. How do you solve that problem? And in the end, how do you generate a revenue out of it? This is an example in a smart grid application where we have done the deployment, starting from the bottom, going all the way to the up. How do you solve a problem in a smart energy or a smart industrial application, where again you have legacy devices, they are communicating on many different applications. Each one may have a different pricing model associated with it, and how do you capture that information, bubble it up, and associate the pricing to that particular data. That's all I have.
Question or two? You're off the hook. All right. Thank you. All right. Now, before our last presentation, I want to point out something. You've been at an event by the Wireless Communication Group, and we've got 10 presenters, 10 PowerPoint presentations, and there has been no issue with the slides. Right? Now, there are billion-dollar companies that can't do that. So I just want to point that out. A round of applause for the logistics tonight. Peter and his team have done a great job. Thank you. So for our final presentation, we have Marty Fabry. He's co-founder of Median One and heads the company's customer success activities. He's responsible for deployment strategies and the company's simple, easy-to-use model for IoT developers. He leads the company's usability efforts, working jointly with customers, strategic partners, and Median One's R&D team to design and implement IoT solutions that bring value to its customers. So please join me in welcoming Marty.
Last but hopefully not the only sleepy one, 3 slides. So at Median One, we're about data intelligence in real time. There are many connected devices. A connected device is really not a smart device unless you really take advantage of its big data. Big data means historical data, data across the context of many devices, different types of devices, and also then applying various other custom logic that applies to your application. So that is our vision, that is what we do. And we do that with our data intelligence platform, which underneath it provides many services that are simply musts today in big data processing, scalability, security, seamless real-time analytics. But then there is the special aspect of it. And what I will point to, a couple of these are flexible real-time workflows. So flexible real-time workflows are our way of approaching the many applications. There are no 2 applications that are alike. And you want to be able to develop something that is unique to you. That's why you have the product, your own product differentiation. So what we provide is the ability for you to execute any program upon any event that comes from your IoT devices. Now that's really powerful because you're not comparing only as my temperature reached the particle threshold. That's relatively straightforward. You want to apply hysteresis, filtering, various data processing on your incoming streams of vast data. Well, you want to do that in real time, and you want to do that programmatically, applying your own algorithms. You want to, of course, do that across history, looking at across users. So that's what the real-time analytics is. And then we also offer machine learning. So if you've got your own algorithms, or you want to apply one of our algorithms, we allow you to also do that. I won't go through this. I will only say that the real beneficiaries of big data are really everyone. It ranges from the developer who wants to quickly develop a new feature, tinker, prototype, and try something that has never been tried before, to the business operations or the marketing people, the folks who want to understand how is my product doing, how is it behaving in the field, what's the user behavior, what's the product behavior. You want to understand productivity, you want to detect anomalies, you want to really have that deeper look into what your data is actually showing you. So those are really the end beneficiaries. The end result is providing those insights and the real-time value of the data that the data itself is showing you. I will explain any of this and all of this if you're interested. Feel free to come and stop by. We have a real-time live factory demo showing here. Basically, it's a use case where we have a live factory productivity monitoring, and I invite you to come and discuss further at any level. Thank you very much.
All right, questions? Wow.
When is dinner?
When is dinner?
When is midnight snack?
Okay, cool. Well, thank you, and thanks for that. Now, that's the last of our presentations. We have a couple minutes more for a little bit of a round-robin Q&A from our presenters. So, now, first of all, do you have any burning questions for a particular presenter that you'd like to get out before we do the final question? Any burning questions? Any inquisitive minds here? So you all know how to create value from the IoT now. Great.
We've been taught.
All right. So billion-dollar companies, all y'all will be founding those right now, right? Okay, good. Now, actually, the truth of the matter is just the fact that we're here sacrificing a beautiful rainy Thursday night, which has been actually quite common this winter here in Silicon Valley. But the fact is that there are probably folks in this room who are going to actually figure it out, and that's what's exciting. So my final question to each of the panelists is the same, and they were kind of prepped with this question before they got here. But when we're looking at finding value in the IoT, in any part of it, but particularly tonight's topic is the industrial IoT, there's a lot of hype out there. So the last question is, how can we tell the difference between hype around an industrial IoT solution and an industrial IoT solution that's actually creating value? And I know you've kind of moved around the room, but I'd love to get each of your thoughts on how we see, how do we filter out the noise from the actual value creation? So I'm just going to start this way. If y'all want to come back up here, I've got the microphone, I want to hear your answers. We all do too. How many of you want to be able to tell the difference between BS and real value? Okay, so it's a good question, right? Let's hear your answers. Oh, all right, then come on up. Peter says come on up. So come on up and tell us how we see the difference between the hype and the real value in IoT.
So the way I separate hype from reality is a platform that you can actually play with and see what your value add is. There are a lot of different types of platforms out there, Wi-Fi, Bluetooth, Zigbee, number goes on and on. So if somebody tells you, okay, I have this particular thing that's good for IoT, ask them for a platform that actually helps them figure out what is their value add by allowing them to port their IP into whatever platform you got and then get it out in the market. So that's the way I would separate it. Actual hardware that shows the differentiation between BS and what's real.
Good. We'll go with Vincent next.
I think the connectivity portion will be where I think the real value will be created. Just from my experience, but there's a lot of analytics that will later on bring value, but for the time being, I think connectivity, which will save a lot of man labor time to hardwire things, but also be able to transmit data at a much faster and larger rate than traditional methods.
Interesting. So if we were to look at the gold rush and the IoT, this would be the guys that built the ships that brought the miners, right? They made money. Okay, connectivity, we got it. And somehow that gold had to get somewhere afterwards, right? Somebody made money in that process. A lot of bankers made money in that process. So I think you might be onto something there.
So I came to talk about Bluetooth, and is Bluetooth hype or is it reality? So Bluetooth ships 4 billion units a year between cell phones and other devices. So I think Bluetooth is here to stay. But if you have something that ships in those types of quantities, imagine the innovation that happens when there are markets that consume 4 billion of those units. So you're going to see a lot more innovation within Bluetooth. There's Bluetooth 5. It's increasing the range by 8x. So basically what ends up happening is you're talking about 2 miles of distance with Bluetooth 5. You have things like Bluetooth mesh that are coming that will allow you to repeat signals. If something ships in those types of volumes, the price of that component goes down. So the volumes are just going to go up with Bluetooth. So I think it's here to stay.
All right, so we're going to find value with Bluetooth. Got it. All right, so next.
Just a quick comment. Since most of my...
Hello?
Since the question that you ask is also our challenge, it's always a question of who will benefit who's the beneficiary, as I said in one of my slides. Who will benefit from the IoT, from the big data, from the additional new item service. And at this point in time, there's still a lot of education out there. There's still a lot of kind of exploring the options. But ultimately, it's when we discover those, hey, hold on, this is an interesting thing, and very quickly going from the discovery to, oh, I actually can't be without this. And the show of something becoming indispensable or very, very useful to a business, that is really the way to discern whether something is real or not in the space of IoT. Back to your question.
I agree with you. I think even the Jabil example I put up there, scanning the QR codes on those PCB boards, we wouldn't do it without it now. And that's IoT, that's sensor-driven data. So I agree. All right.
Okay. Hello. Okay. I'm going to say something very obvious, but I think this is really the key. It's really identifying a high-value problem to solve and create a solution for that. And it sounds obvious, but there are so many examples of people adding Bluetooth to a toaster or some object, and just because you can do it doesn't necessarily mean you should do it, because it doesn't drive value. So there's lots of noise in those types of applications. And I would sort of build on that and say that one of the challenges ultimately is there are people who understand where there are valuable problems, but don't necessarily have the capabilities built in-house to actually solve all of those problems. Someone who is dealing on a factory floor is not an electronics expert. They're not, so they'll buy modules or they'll try to simplify that process to design something. So I think there is the opportunity there, is helping provide those solutions in a very simple way.
Good. All right, last but not least, right? Is this the last one?
Yes.
All right. You get to sum it up for us. Where are we going to find the value in the industrial IoT and miss out on the hype? How do we do that?
I think I would like to answer the question of, can I create the value and capture that value?
He's going to run for president.
I think a lot of the industrial IoT applications that we are seeing today, the value creation is happening, but the value capture is being done by the end consumer. So as a business, the challenge I'm running into is that most of the customers we are working with is, how do we help them capture the value? And when we talk about capturing the value, that means the diagram I showed can I create new revenue models to get that money back? Otherwise, I am mostly optimizing the processes for my end customer. You can only go so much on optimization, after which the value capture goes to the customer. So I think when we talk about the value capture as a service model or new business models of creating or going into the market is something we have seen. The companies who are able to do it are successful, as a service model, as a maintenance model. And I think that's a way to, I think, create and capture value in myself.
Thank you. All right, I'm going to give you all a homework assignment. If you have had an idea for a way to create value from the IoT, do it, especially in the industrial IoT. I want to see tremendous amounts of value created in this space. It's a fantastic space where we can really put technology to work for us. Like all these panelists, they've all had their email addresses up there. If you want to get a hold of them and you haven't been able to copy down the addresses, I'm sure Pete would be happy to connect you. I look forward to engaging with you further in this space in the IoT. Please join me in thanking the organizers and our panelists and everyone who's participated.
Thank you very much, Josh, and all the speakers, thank you very much. We've got about a half hour, so please, all the presenters are here. Have a take a look at their demos, and we'll adjourn the WCA event, and please tune in to our website. Thank you very much.
Yeah.
Nobody's ever told me to do that. I used to wear a jacket when I have a colored shirt on because I was sweat.
Right.
I'm not trying to outdress anyone. It's really because of the sweat.
But it looks sharp. That's what it comes down to. So, here, let me give you my card.
Did I give you one?
I don't believe so.
No, but we are connected on email already.
Yeah, exactly.
You should come on over and we'll
chat. Yeah.